we now reach the exciting conclusion to yesterday's lesson, L'Hopital's rule. And I've already got it here on the screen. This is actually something that I sort of informally taught last year, so you may have picked it up right at the end of last year, but I'm formally teaching it now, and it goes beyond what we learned last year. So L'Hopital's rule, strictly speaking, is a method that lets us deal with indeterminate forms. So strictly speaking, here's what it says. If you have a limit of like f of x over g of x, so if you have a limit that approaches 0 over 0 or infinity over infinity, if you have a limit like that, then you can take your limit and instead simply take the derivative of the top and the derivative of the bottom and try the limit again. This is like amazing. In fact, when a lot of people, when they learn this, they get upset that we did all of chapter 1. Because they're like, dude, why do we have to do chapter 1 if we can do if every try harder problem can just be done using L'Hopital's rule? Well, not quite all of them can. There are some where you need some other methods, but they're really hard problems. But this is great, right? What it means is if you've got a limit that approaches these things, just take the derivative of the top, take the derivative of the bottom, and try again. What if that limit is also 0 over 0 or infinity over infinity? Good news, just do it again. Take the second derivative over the second derivative. If it's still 0 over 0, take the third derivative over the third derivative. Eventually, it won't be one of these, or it'll be one of those really wacky problems that I'm not planning to give you. But this is L'Hopital's rule, right? One quick note. This does not replace the quotient rule. I'm not saying take the derivative of this, hey yay, we don't have to do quotient rule anymore. No. This is a very specific thing called L'Hopital's rule. If you have one of these limits, then you can do this. You can take a different limit. You can take the derivative of the top and the derivative of the bottom and try the limit again. Okay? So we're going to do a few examples of this. So this first problem. The limit as x approaches 0 of the sine of 5x over x. You may remember these problems from last year. Back in chapter 1, we would use a method where we would like multiply top and bottom by 5 and then pull the 5 out. Like we had a method for it. But now we can look at this problem and say, okay, well, the limit as x approaches 0. If I attempt to plug in 0, I end up with 0 over 0. That is 0 over 0 or infinity over infinity. Therefore, I can use L'Hopital's rule. You don't need to write that down on your paper, but I want you to recognize L'Hopital's rule can only be used if you have 0 over 0 or infinity over infinity. So when that happens, we keep our same limit. The limit as x approaches 0. The derivative of the top is 5 cosine 5x. The derivative of the bottom is 1. And now when I attempt to evaluate this expression for 0, when I attempt to plug in 0, I end up with 5 cosine 0, which is 5. And 5 is not an indeterminate form. 5 is a number, which means we found our limit. This is L'Hopital's rule. If you have something that approaches 0 over 0 or infinity over infinity, you may do this process to figure out what the limit is. So here's another example. This is an infinite limit. You may remember these problems last year as the kind where we divide top and bottom by the highest power of x. Great, that works, right? Take a minute and work through this. Take a minute, see if L'Hopital's rule applies, then try using L'Hopital's rule. If I attempt to plug in infinity, I'm definitely going to end up with infinity over infinity. So, because of that, I can use L'Hopital's rule. Great, so how do we actually use L'Hopital's rule? Well, we keep the same limit expression, the limit as x approaches infinity, but now we take the derivative of the top, 6x minus 4. And we take the derivative of the bottom, that's 3x squared minus 4. When I attempt to take the limit again, I end up again with infinity over infinity. And so what does that mean? Well, that should mean that we can use L'Hopital's rule again. And so since we can use L'Hopital's rule again, we'll try one more time. The limit as x approaches infinity, the derivative of the top is now 6. The derivative of the bottom is 6x. And we could cancel the 6's, but to be honest, it doesn't really matter to me. This is approaching 6 over infinity, which is approaching 0. Notice that I broke out of the cycle of indeterminate forms. I had infinity over infinity, I tried L'Hopital's rule, I got infinity over infinity, I tried L'Hopital's rule again, and in this one I got some number over infinity, which is not indeterminate. I know that this is 0. Here's my last example. I'll let you guys have the opportunity to work this one out, so pause the video and try it. When we attempt to take this limit, we end up getting infinity over infinity, which of course means that we can use L'Hopital's rule. I got cut off the screen. We can use L'Hopital's rule. Great. So I will use L'Hopital's rule. the limit as x approaches infinity of 2e to the 2x over 2x minus 3. This is still approaching infinity over infinity, which means I can still use L'Hopital's rule. Right, so one more time, I'll take the limit as x approaches infinity of 4e to the 2x over 2. And again, we could simplify that, but it doesn't really matter because this ends up being infinity over 2. And infinity over 2 is approaching positive infinity. Right? And so now it's sort of up to the context of the problem whether this is infinity, whether it does not exist. Remember those two things are similar but different. This limit is approaching infinity, which is a specific form of does not exist. Okay? So this is how L'Hopital's rule works. It's a rule that you can use anytime your limit is approaching 0 over 0 or infinity over infinity. It's fantastic, it's marvelous, but it may only be used in those two cases. If you try and use it anywhere else, bad things happen. You get wrong answers. I think my closing comment is this. We learned in yesterday's lessons that there are 7 indeterminate forms. This video covered 2 of them, 0 over 0 and infinity over infinity. So how do we deal with the other 5? I'll be honest, I'm not going to cover infinity minus infinity in the next 2 videos. It generally isn't covered on the AP or the IB exams. I may show it in a later optional video at some point, but for now, expect to see those the other 4, and we'll be looking at those shortly.